Hey everybody, so in this video we are going to take some time to go through the 6 questions that you just looked at today on your study guide, and we're going to get right into it, that way we have enough time in the video. So goal number 1, you can find the unit rate, which is the same thing as the constant of proportionality, from a graph. So again, we looked at 2 ways to do that. So here's our graph, right? We're comparing, we have concert tickets, right? So we're comparing the number of tickets that we can buy for a certain cost. They want us to find the unit rate, or the price for one ticket. So we learned one of the ways we can do this is find where x is equal to 1. Kind of think, do your little highlighting, and then figure out where does the diagonal line hit x equals 1. And it's going to be right about here, right? Usually that was helpful, but in this case, the reason that is not super helpful is because of our scales, right? That's not really a clean, easy point to use. So I'm thinking for this problem, we're going to want to use option 2, which is to pick any point on the line. So maybe we pick this one, right? That's a point on the line. It also matches up nicely with the grid, so we can use that one. So thinking about our coordinates, right? X comma y for that point. To get there, you have to go over 20. So that's our x value, and you have to go up 100. So that is the coordinate for that point, right? That's the location of it. So I'm just going to come back to the side and say again, so we have 20 comma 100. So that tells us 20 tickets costs $100. Again, our coordinates are always in the form x comma y. So 20 is our x, and 100 is our y. So in order to find the unit rate, all we have to do, let's do y divided by x. So 100 divided by 20 gets us a constant of proportionality, or unit rate, of 5. So that means the unit rate is $5 per ticket, which isn't too bad. And that's how you would find it in that graph. Let's take a look at number 2, which is, again, having the same goal. So we're talking, again, from this graph, it's the cost for exceeding the minutes that are allowed on a cell phone plan. So on x-axis, we have our number of minutes, and on the y-axis, we have our total cost. And they want us to figure out, again, what is the unit rate? So we could have done what we did in the last example, and maybe we'll do that again. But let's try the first option, right? Let's find where x is equal to 1, which is right here. Here's the point on the line when x equals 1. And we said, well, let's just figure out how high up that point is. To me, obviously, it's between 0 and 1. It looks like maybe 0.25, so 25 cents, or possibly could be 50 cents, right? It's kind of hard to tell. So we're between A and B for sure. $1 and $4, that's out of the question. So let's go back. So that was option 1 of finding it. Let's quick calculate option 2 and just double check. So same thing. For this point, we go over 4 and up 1. So 4 is our x value, 1 is our y value. So if we do, for our constant of proportionality, y divided by x, we're going to do 1 divided by 4. And if you put that into your calculator, you should get 0.25, which is the same thing as 1/4. So that tells us that A is going to be the best answer here, right? For every minute that you go over your allowable limit, you're going to be charged 25 cents. Okay, so again, both of these examples used our 2 methods as well. And if you scroll all the way to the bottom, the last page, you're going to see the 2 strategies for finding the unit rate or the COP from a graph. And you can review those. Okay, let's go to the second page and look at number 3. So this goal for this page, I can explain the meaning of points on a graph. So for number 3, we're comparing the cost of tangerines, right? So the x-axis is the pounds that we purchase, and the y-axis is the cost for those. So when you see a question like this, you just have to go through the options. So the cost of 1 pound of tangerines is $2. So if we go over to 1 pound and we go up to 2, the line doesn't touch that point. So that's not true, right? 1 pound of tangerines actually costs like $2.50. So that one's wrong. How about answer B? So we'll go over to 2 pounds, and they're saying it costs $1. Not true, right? That one is not on the line either. How about part C, answer C? 2 pounds of tangerines, so over 2. If we go up, where do we stop? We stop at 5, which is true, right? 2 pounds of tangerines equates to $5 of cost. So I think that's the right answer, but let's just check letter D. 5 pounds of tangerines, right? This only goes up to 3 for pounds. So we really don't even have information on D, so we can cross that one out. So 2 pounds of tangerines will cost us $5. Okay, this page is all about fruit, I guess, because number 4 is going to be talking about the cost for bananas. So same thing, we have number of pounds of bananas versus the cost for those. So that is going to be what we're comparing, right? Pounds to cost. So if they want us to set up our table like this, we can start by including our labels, right? And again, pounds goes first because that's the X, and cost goes second because that is our Y. Okay, so all we have to do to start filling in these rows is to look at our graph, right? Well, we have point Z. That's the origin, so that's 0, 0. Point Y, right? To get to there, you go over on X, right? You go over to 1 pound, and then you go up to, in dollars, 0.60. For point X, 2 pounds is going to cost us $1.20. And then finally, for point W, that's going to be 3 pounds, costs us $1.80. So again, these points were Z, Y, X, and W from the graph. Okay, so we made our table. Part B asks us, what does the point 0, 0 mean? Right? Think about what we're comparing, pounds to cost. So what happens when pounds are 0? Well, cost is also going to be 0. So you can write this any way that you want, but really for shorthand, I'm just going to say that no pounds, right? If we buy no pounds of bananas, doesn't it make sense that we won't have a cost, right? Why are we going to pay for something if we didn't buy it, right? So no pounds of bananas is going to equal to no cost. All right, we'll look at another one. What does the point 1, 0.60 mean in this table? So that is going to be our point Y. Again, 1 is our X value, and 0.60 is our Y value. So all that means is 1 pound of bananas is going to cost us 60 cents, or you can say $1, or sorry, you can say the $sign 0.60, but that means 60 cents. So that's all that point means. Part D wants us to think about what is the cost for 1.5 pounds of bananas. So if we go over back to our table, we need to find where pounds is equal to 1.5. So there's 1. Here we go. There's 1.5. So then if we just climb our way up, you're going to see that the height of that point is 90 cents. So that's what it's going to cost if we wanted to buy 1.5 pounds of bananas. Okay, part E, the final question for number 4. How many pounds of bananas can you get for $1.80? So the cost is $1.80. We're going to go over. The point that hits the line is going to be 3 pounds. So that's how many pounds you can get for that price. Okay, scrolling to the third page. So goal number 3, I can create a graph to represent a proportional relationship. So we're talking Chick-fil-A here. So $3.50 for each chicken sandwich that you get, each spicy chicken sandwich. So one of them is going to cost $3.50. So just start thinking, how can you fill in the rest of this table? Maybe you want to find the price for 2. That would be $7. What if you wanted to find the cost for 3? That's going to be $10.50. right? And you can just start filling in that however you want, right? And again, this was just we got this by just multiplying by 2 for each row. And that found us the price for each number of sandwiches. So if we want to make a graph, first thing we need is our title. So maybe for sake of time, I'll just write Chick-fil-A. You can be a little more specific if you want. We need our labels for our X and our Y axes, right? Well, in our table, we said X is always the first column and Y is always the second column. On our graph, X always goes across, Y always goes up and down. So we just have to put these in. So X, I'm just going to write number of sandwiches. And then for the Y, we'll just write cost. Okay, so our labels are done. The next thing we need to do is put our scales on, right? So what numbers are we going to write for each of the axes? That's what you have to think about. So looking at the number of sandwiches that we used, at least in this example, I only did it 1, 2, and 3. So my lowest number is 1, highest number is 3. You could have made it 1, 20, and 300 if you wanted to. That's fine. But since my numbers are small, for my scale, I'm going to skip a box. So I'm basically going to go every other box for my numbers. That way I only get 5 across and I can spread out my work. But for the cost, lowest is $3.50 and the highest is $10.50. So I think for this, I'm just going to go each block is worth $1. So that'll get us at least up to 10, and we might just have to go off the graph a little bit, which is okay. So 7, 8, 9, and 10. All right, so we have our scales. And again, there's no right or wrong way to do those scales, right? You can make them whatever you want. Just make sure you're consistent and you don't skip any numbers. That's the big thing. So okay, we did our scales. Now we're just going to put our points on. So one sandwich is equal to $3.50. Which is going to be like somewhere up there between 3 and 4. Two sandwiches, it's going to cost us $7. So I'll put our point there. And then finally, 3 sandwiches, we go all the way up, is going to cost us about $10.50, which is just slightly off of our graph. Okay, so we have our points in. We can also put that 4th point in, right, the origin, because if it's proportional, it'll always cross through there. And then the final thing we need to do is just connect these with a line. And we can just make sure that it'll connect with a straight line, which looks like this one does. I just have to adjust it a little bit. No, okay. So the shape is a little bit off, but you can connect all of these points with a straight line, which tells you that it is going to be proportional, which is great. All right, real quick. Goal number 4, I can tell whether a relationship is proportional or non-proportional and explain why. So you have one table and 2 graphs here. So again, we said if we have a table, right, here's our X and here's our Y, in order to find that if it's proportional or not, we have to do Y divided by X for all of the combinations. So for the first one, Y is 4, X is 1. 4 divided by 1 gets us 4. For the second one, Y is 8, X is 2. That's going to give us a 4. Looking good so far. How about the third one? 16 divided by 3. That is not going to give us 4. That's going to give us about 5.3 repeating. Right? So because there's even one of these different, I'm going to write NP, right? Not proportional. And I'm just going to, for the sake of the video, I'm just going to draw an arrow to this one being different. All right, part B. This one is going to be proportional. It's a straight line through the origin, right? It's a straight line and it passes through this point. So we can write that down. And then finally, for our last example, this one, another graph, not proportional. It is a straight line, but it does not go through the origin. So I'll just write not origin. And that is all you would need to explain there. Okay, so again, hopefully that video helped. Again, the last page in your packet is all about your little resources. So use those as you're doing some practice. But thank you for checking this out, and hopefully this helped you.